All right, you guys, let's jump into those examples. Find the derivative of f of x at a, then find the equation of the tangent line. Okay, let's try this out. Just gonna switch cameras. Okay, here we go. Again, there's our instructions. Part A, f of x equals x squared plus 2x minus 1. We're doing this at a equals 3. Let me copy our formula for the derivative. And what we can do just to get us started is plug in a equals 3 everywhere it appears. So we're trying to find, for the derivative, f prime of 3. It's the limit as x approaches 3, f of x minus f of 3 over x minus 3. And this is a good way to get started. We can go from here. What will we do next after we plugged in 3 for all of the a's? Say, okay, well, the limit will perform last, obviously, right? X minus 3. Let's figure out what f of 3 is. And you know what? Even at the same time, f of x, let's go ahead and plug that whole thing in. F of x is x squared plus 2x minus 1. And then we're going to subtract f of 3. Well, we would find that by plugging 3 in to the function. So what would we have there? 3 squared would be 9 plus 6 is 15 minus 1 is 14. So x squared plus 2x minus 1 minus the 14, still over x minus 3. We still have the limit as x approaches 3. Okay. What can we do? Let's simplify here. And then hopefully we'll have the skills to figure this out. Minus 15 over x minus 3. All right. Let's see. In order to figure out this limit, well, we have this rational function. I don't think we're going to be able to plug 3 in. That would give us 0 over 0. So instead, in this situation, we know, all right, we need to simplify. We can do that here by factoring. And we're hoping that after we factor the numerator, that x minus 3 factor will cancel out. Let's see if it does. X squared plus 2x minus 15. X minus 3, and the other one could be x plus 5. And that would give us plus 2x in the middle, minus 15 there. Oh, that's incredible. Look at that. They cancel. We're doing the limit as x approaches 3 for x plus 5. And now we can plug in, and our answer for the derivative is 8. Pretty sweet. Okay, well, there you go. Then it says to go one step further and find the equation of the tangent line. So here we know this is the slope of the tangent. How are we going to find the equation of the tangent line? You guys remember that formula y minus y1 equals m times x minus x1, the point slope form? You can use that. We know the slope is 8. And if we can figure out a point on the graph, then we'll have it. And we know a point. We're going to use a equals 3 as our x value. We also already plugged that in and found the y value. We did that already and got 14. So we know that m equals 8, and it passes through the point at 314. Again, that's our x value where we found the derivative, and plugging that into the function here, we already did that before. We know it's going through 314. So the equation of the tangent line, we can say y minus 14 equals 8 times x minus 3. And let's see if I can do this. 8 times x, and then 8 times -3, -24. But then we're going to add 14, and that's going to leave us with minus 10. There's the equation of the tangent line. That's pretty amazing. Okay, before we go to the next problem, we gotta pause here. We have to pause and graph this. Let's check it out. So over here in Desmos, I'm gonna graph that function, x squared plus 2x minus 1. Okay. Now we're curious about what's happening at 3. Let's even plot the point at 3, 14. Just kind of zone in on it. All right, there it is. So we're thinking there's going to be a line that comes up and it just barely grazes past, touching right there at that purple point and then moving on. We know the slope of that line is 8. And we even found the equation of the line as 8x minus 10. And look at that. Wow. If we zoom out a little bit, that's pretty sweet. That black line just comes up, nicks that purple point, and then keeps moving. Right at that moment, the black line is moving in the same direction as the green, but then the green continues to curve up a little bit, and as you zoom out, you kind of maybe get a little bit better image of what's happening up here. There you go. Isn't that incredible? I mean, if somebody came and said, hey, what's the line that will just barely come and touch that one point and keep moving without touching in the graph anywhere else? You'd be like, wow, that's super difficult. I can barely draw that, let alone figure out, what the equation of that line would be. It sounds impossible. But we did it. And we did it in, a page of work. But considering that doesn't seem like that much compared to what we were able to accomplish there. That's pretty incredible. Okay. I know. Let's look at part B. F of x equals the square root of 2x plus 3. We're going to do this at a equals 11. That looks like fun. Let's see. A square root's involved. We're going to be doing a limit. So we're kind of thinking like probably a conjugate. It's going to happen. Let me, again, just start by just going to copy our derivative formula here. And I'm going to plug 11 in for all the a's. So it's f prime of 11. Limit as x approaches 11. F of x minus f of 11 over x minus 11. No need to get ahead of myself. Just do this nice and methodically. Okay, once I have the a plugged in, then I can replace the f of x, and I'll go ahead and calculate f of 11 at the same time. So square root 2x plus 3, f of 11. Let's see, plugging that in, I'd have 22 plus 3 is 25. The square root of that is 5. That works out pretty nice. All right. Okay, let's see from here. Well, again, like Obviously, we can't plug in 11. That would give us 0 over 0. We've got a conjugate happening, or we need to make a conjugate happen, I should say, in order to simplify this. So take the conjugate of that numerator. And let's see what happens. So the first times the first, that's just gonna end up squaring my square root. So that's gone. I can see that the outside combined with the inside products, those are just gonna cancel. And then finally, we've got -5 times +5 minus 25 over in the denominator. I'm not going to FOIL. I'm going to keep it just like that. And we can continue to simplify here. Let's see. 2x plus 3 minus 2 minus 25 is 2x minus 22. And we can see, yeah, we're going to be able to cancel this. We're going to be able to cancel out the x minus 11. 2 times x minus 11. It's kind of moving along. Cancel out. Two over square root 2x plus 3 plus 5. And finally, now we can plug in. Once I plug in, we'll no longer write the limit in front. Plugging in 11, well, 22 plus 3 would be 25. Square root is 5 again. So 5 plus 5 is 10. 2 over 10 is 1/5. There we are. Again, that is our derivative answer. That's the slope of the tangent line. If we then wanted to find the equation of the tangent line, we'd say, all right, I know my slope is 1/5, and I know this passes through the point at 11. What's the y value at 11? We already found it earlier. F of 11 was 5. So it's at the point 11, 5. And then I can use my point slope form from algebra. Y minus y1 equals m times x minus x1. Might not have thought about point slope form for some time. Turns out it's really important in calculus for finding the equations of tangent lines. We're going to use it quite a bit. So, okay, let's see if we can go straight to a final answer here. So 1/5 x, I'm going to grab my calculator, 1/5 times -11, and then we're going to add 5. That gives me plus 14 over 5. There's the equation of our tangent line. Pretty nifty. Hey, let's graph it for sure. Y equals square root 2x plus 3. Okay. Passing through the point at 11.5. There it is. Zoom in a bit. And we found, wait for it, there's the slope 1/5, but now it's got to move upwards. There it is, incredible. 1/5 x plus 14 over 5 passes through that point and just grazes by, moving in the same direction as the red curve right at that moment. It's pretty incredible what we're able to do with limits. And, you know, just it's we're finding a slope and then we're taking a limit, right? Pretty amazing. Okay. It actually blows me away. I mean, every semester I teach this, and I mean, I've been teaching calculus for over a decade, but, you know, even going back to when I was a student, but especially as a teacher, and you kind of reflect more on these things at that point. I mean, that's just amazing that we can figure out the equation of that line. And, you know, for you guys, you're like, well, you know, you're just kind of just learning it, so it doesn't really have the impact. You're just like, am I going to do well in this class and on quizzes and stuff? This is incredibly, incredibly powerful. I mean, what if somebody like drew that graph and then, you know, just laid down this point and said, hey, you know, figure out the equation of that line. You're like, what? Like, that's impossible. Nobody could do that, you know, but, oh, turns out, oh yeah. Okay. That is it for this video. We'll do more in the next one.